conference will now be recorded.
Also, we have seen some of the examples, and we have seen what is the containers, what is the Docker, how the Docker will be, and uh, how the traditional IT started with, and it evolved into the different situations like year by year. So we have seen all these things. Now, so okay, before I start with today's class, any questions on yesterday's class? Any questions, any confusions? Guys, I would like everyone to respond back.
Yeah, no questions.
Okay. So if there is no questions, then from today on, we will continue in this manner. Okay. So that is 1 second. So with week 1, 2, we'll go with Docker fundamentals. And then the next weeks we'll go with Kubernetes and Terraform, Terragrunt, Gitlab, and then we'll discuss on advanced projects and integrations. Okay, so this is how we will be going. As a part of this plan, the first thing that we will be learning today is about the Docker. Okay, so before I start, how many of you know about Docker or what Docker is? Okay, so so now let's say before we dive into Docker, let's first understand what container is. Or traditionally, the applications were directly deployed on servers. This caused dependency issues. It works on my machine, but not on production. So now the problem which we are facing or which everyone facing is related to the dependency issues. So then the containers solve that issues. What containers will do? Containers will deploy the packaging by app plus its dependencies. That is traditionally, traditionally in the sense earlier applications were deployed on servers. This caused dependencies issues. That is what type of dependency issues? The first and foremost dependency issue is it works on my machine. It works on my machine, but not in production. So this is the main cause which we see while deploying into the containers. Okay. Now, so because of that, what was happening? The duplication issues or the conflicts, all these things used to come. So now to resolve that issues, containers solve this issue by packaging the app plus containers or the app plus dependencies into one unit. This is called Docker containers. Now, what is firstly, what is container? It's a lightweight portable package runs on top of an OS kernel isolated from other apps. Containers or contains everything like app code, library files, runtime. Okay, this is called a in general container is. What container is? Container is nothing but it's a lightweight portable package, or it's we can call it as lightweight portable bundle where it runs on top of OS with isolated from other apps. That is, if suppose let's say if you want Nginx, if you want to deploy in a container, it will go ahead and run the Nginx application, but it will run along with the operating system, its app code, its libraries, everything. So that what happens now, let's say if I have version 2 and you're using version 3. Now, if I want to deploy my app on your machine, version 2, version 3 won't suffix. So now what container will do? Container will deploy the version 2 dependencies along with the app. So that now what happens when you were trying to deploy the container on your machine that I have created, it will go ahead and directly deploy along with the version 2 dependencies. So this is why container we will be using, and this is the reason why solving the issue of it works on my machine but not in production. Clear everyone on this? Any questions?
Okay.
Okay. Now let's say why container versus traditional deployment. Traditional app depends on system libraries, that is, breaks when moved. Now the containers is always connected or consistent. Same app runs on laptop, server, cloud, anywhere. So this is the difference between traditional deployment and container deployment. That is, when traditional deployment app depends only on system libraries. breaks when moved because your your application is dependent on the server libraries but not on the app libraries. Now the container has everything installed which is consistent so that your app runs on your laptop, on your server, on your cloud or anywhere. Okay. This is called the difference between containers and the traditional servers deployment. Analogy, if you take the analogy, containers equals to sealed lunchbox. You can call it as traditional apps equals to open plates, that is spill and mix. So if you take the analogy, that is containers, you can call it as sealed lunchbox. So let me take, so now tell me if you have a plate and plate full of rice, dal, curry, or whatever it is, can you carry that plate anywhere? No, right, because it will, while traveling, it will go and spill and mix. So the traditional servers are like that. We can't carry anywhere. We need to use in that particular server itself. But coming to containers, it is called a sealed lunchbox because the same plate full of rice, dal, chapati, curry, whatever it is, you'll put nicely into a different boxes and you'll seal that box and you can carry anywhere. You can open the box and you can eat anywhere. So now the containers are like that. Containers will consist of its own application, its own app code, the application dependencies, everything, so that wherever you go and deploy, it will deploy along with the dependencies. That's the reason why containers will go ahead and work anywhere. Now, is it clear, everyone, on this? So, if I need to give you a real-time example, you can see or you can search this in the Google as well. Netflix runs 1,000 containers daily, and Uber scales ride matching with containers. And PayPal, if you see the PayPal have recently migrated everything of their servers into containers, which runs with faster deployments. Clear everyone on this? Any other questions, confusions? Okay, if there is no questions, then we'll see the next topic, that is Docker versus virtual machines. Okay, so we just saw that what container now is, and you understand the container and what container is. And now let's compare this virtual machine with container. Okay, now before I start with comparing virtual machine with Docker, what is virtual machine? Virtual machine is nothing but it's a kind of laptop. So laptop, you can see system, you can see server, you can see physically. Whatever the devices you can see physically, we call it as physical machines, and the same devices you can use it but you can't see it. Then we call it as virtual machines. So we'll have these virtual machines deployed on cloud or on our on-premise servers as well. So now let's understand the difference between that particular virtual machine as well as Docker. Okay, now virtual machines. Each VM includes guest OS, libraries, and dependencies application. So now here, what a virtual machine consists of. Virtual machine consists of a OS, that is operating system, either it could be Windows, Mac, or the Linux, and then it consists of the application libraries and its dependencies, that is version numbers, version 1, version 2, version 3, or whatever it is. And then it will also contain the application. So then what virtual machine needs a hypervisor, that is VMware or Hyper-V. So hypervisor is nothing but it's a application where you can start your virtual machine. So physical machine, you have buttons, you can click on that button and your laptop or physical see computer will start. But what about the virtual machine? So virtual machine also should have something to click on that button to start. And that button is nothing but hypervisor. If you open hypervisor, you'll have all the list of virtual machines over there and you can click on that virtual machine to start it to start. Okay, and then heavyweight, which consumes GBs of space, takes minutes to boot. Good for complete isolation, legacy apps. So all about the virtual machine. Clear everyone on this? Any questions? Any questions? Any confusions? Okay. Now let's talk about the containers.
Kiran,
Yeah.
may I know what this legacy apps means?
Legacy apps means old applications or standard applications. Like let's say Office 2007. Office, so Microsoft Word is there. Microsoft Word, we have 2007, we have 2025. Now 2007 is called legacy application. 2025 is called latest application. Like this. Clear?
Yeah, thank you.
Okay. Now share the host OS kernel. No need for separate OS. Only include the app dependencies. Lightweight, that is MBs. in size, start in seconds, run more containers on the same hardware versus fewer VMs. Perfect for microservices, cloud native apps. Okay, so this is all about the containers. What container is? Container is nothing but it will share host OS. That is, whatever the application consists of the same operating system, it will share. It won't install separate a different OS again, and then only include app plus dependencies. Applications plus its dependencies will only be included. But here it has its libraries, guest OS, application, and dependencies, all this. But here, if you see, it only includes app plus dependencies. That's why this is heavyweight, this is lightweight. This consists of GB, this consists of MB. And then run more containers on same hardware versus fewer VMs. That is same same hardware, whatever the container consists of. The suppose let's say I have a laptop or I have a desktop, that is my hardware. Now all my containers will run on the same hardware. That is, if I have 10 GB of space, I can go ahead and install 100 containers. But coming to virtual machines, I can only install 10 virtual machines, because if we it goes in GBs. So if I give 1 GB for one virtual machine, I can only install 10 virtual machines. But coming to same containers I can install 100 containers, because if virtual machine is 1 GB, the same configuration you'll be having with 10 MB. That is the difference between virtual machine and container. So you can say virtual machine as house, because it builds. Now how can you build a house? You need to have land, you need to have foundation, you need to have walls, you need to set rooms, you need to divide all these rooms, which costs, like, let's say 40 lakhs, 50 lakhs, or 1 crore, something like this. Depending on your capacity, you will build a house. But container is like a apartment. You don't need to install the foundation, you don't need structure, but still it is independent, which is faster to set up and more efficient use of space. Correct? Clear everyone on this? Guys, I want a response from everyone.
Yes, Kiran.
Yes, Kiran.
Okay, cool. Thank you. Now let's understand why Docker. So far we have seen about the containers and traditional virtual machines and its dependencies. Now let's understand why Docker. Okay, so Docker is the most popular container platform because made containers easy to use, portable, and developer friendly. So this is the reason why Docker we will be using. Now let's say for virtual machines, we said VMware is the platform to start and to stop. That's where even for containers, you have Docker is the platform where you can go ahead and start your containers or stop your containers or create or delete your containers. Okay. Now let's say first one, why it is why we call Docker as the developer friendly. Works the same everywhere. Developers, laptop, testing server, production, cloud, same image, same image with no surprises. Solves the famous works on my machine problem. Okay, this is called the first thing works same everywhere. That is, if you try to create a Docker image, try to create a Docker file, that Docker file works on your laptop, on testing environment, on server, on production, wherever you deploy, the image won't change and there is no dependencies kind of thing. And the second thing, faster deployments. In VMs, minutes to boot. VM takes boot. For Docker containers, takes seconds to boot. Great for scaling apps instantly. Third one, smaller size, which saves cost. That is VMs, GBs in size, containers, MBs in size, and run more apps on the same hardware. Next one, huge ecosystem, Docker Hub, billions for pre-installed or pre-built images, that is databases which called MySQL, MongoDB, web servers, Nginx, Apache, and languages, Python, Node.js. For this, the advantage is developers can reuse instead of reinventing. So these are the key benefits of using Docker and its huge ecosystem. That is, we have pre-built images on every application, I would say, like databases, MySQL, MongoDB, .NET SQL, all this. And then you have web servers like Nginx and Apache, and languages like Python or Node.js. Clear everyone on this? Any questions?
Yes, Kiran.
Yeah,
All good.
okay, cool. If there is no questions, then let's go ahead and see some of the live example of, let's say, let's go to Docker Hub. So this is called the Docker Hub. We have already seen on Friday. So then you have the images over here. Now let's try to pick something here. Docker run Nginx. Okay. So what it say? It will go ahead and it will try to install the Nginx application.
Kiran, this is happening locally, right? I mean,
Yeah,
Nginx
this
is
is happening on
installed
local
here.
machine. Yeah,
Okay,
we are trying to install on our local.
good.
Okay, if you see, we have installed the Nginx application and our image is this. And you can go to containers and we have the containers which is like 7.41 MB. We have 7.65 GB of memory where the Nginx is using just 7.41 MB and your memory is 0.09% with the 0% CPU, or it will go ahead and increase 1 to 2% whenever it is required. And then you can see disk read and write is of just 11 KB and 12.3 KB, 1.17 KB or 126 bytes. So this is how you will go ahead and use. So the command for installing any application is docker run nginx. This is the command. Now let's see firstly, I mean, what is, so we have seen why Docker, now see what is Docker. Docker is a platform building, running, and shipping containers. Shipping in a sense, moving from one place to another place, that is, copying the Docker file. It simplifies application deployment by packaging app code, runtime, libraries, dependencies into one container images, that is portable and consistent. This is called Dockerization. So what are the key Docker components? That is image. First component is image, which is blueprint. And the next one is container, that is running instance of image. And the other key instance is Docker file script that defines how to build a Docker or how to build an image in Docker. And the next one is volume, persistent storage for containers. And the next one is network, that is communication between containers. These are all the key components of Docker. Let's see some of the common Docker commands. Command and its purpose. Docker run a container. Docker ps list running containers. Docker images list images. Docker build image from Docker file. Docker exec it id bash open container shell. Docker stop is for stopping container. Docker rm id is for removing container. Clear everyone on this? Any questions, confusions? Okay, so this is all about the basic things of Docker and how we run the Docker. And you have any questions, you can go ahead and ask. If not, in tomorrow's section, we will try to execute all these commands and we'll try to do some practical things. How we did today for Docker installing the Nginx. Okay. Any questions, any confusions, you can just go ahead and ask.
Kiran, this is the first time I'm joining. I mean, the first day for me. So I want to
Yeah.
ask you, like, yesterday we spoke, right? Or are you the same person?
On Saturday, we have,
Okay. No, no. Actually, I called to the person, so I think the trainer, you will be the different, right?
yeah, yeah. Admin is different and I'm the,
It's
tell me.
different. Yeah. Okay. Okay. So actually, I need to introduce myself to you, Kiran.
Yeah,
Um,
yes, Ashmita,
so
go ahead.
yeah, yeah, I have 5 years of experience completely into ETL testing. So
Okay.
now, actually, I just want to move out of. I mean, I have the thing over there. I can go to Databricks or data science in order to elaborate my skill. But I just want to move into this DevOps completely. So, will it be flexible for me after learning this course to get a job? That's what I
Yes,
want.
absolutely. So, because I would say here we are completely covering in depth of the DevOps concepts. So, with this, you will be able to learn what Docker is, you will be able to learn what Kubernetes is, you will be able to learn what Terraform is, what Terragrunt is, what Gitlab is. Now, this makes to make you a complete DevOps or DevSecOps engineer. I would, so you may ask me why or how. Is first thing DevOps, what a DevOps person should need is how to create resources in a automatic manner. So you are learning, for that you are learning Terraform and YAML so that you will go ahead and deploy your instances using CI/CD pipelines. So you got to know how to install the infrastructure. Now the next thing is you should know about deployment of code. So deployment of code depends on either you can directly go ahead and deploy using CI/CD pipeline, or you can directly go ahead and install on the Docker. Now, so if you install it on the Docker, you will create an image and you will deploy it to Kubernetes. So you got to know the set of part of deployment. So mainly the DevOps engineer requires the infrastructure creation, deployment of the applications in a secured and automatic manner. That's what you will learn in this complete course. So yes, after this course, you can directly go ahead and apply for the DevOps position. And as we are also working on the real-time scenarios with real-time projects, it would even help you in the interview processes. And we'll also discuss if for every topic, what is the interview questions that might come when you are attending the interview.
Okay, okay, Kiran. So it will be flexible. Like I can keep completely 5 years and look into the things, or I just
Yes,
want to do some 2 to 3 years
you can put
experience because
you
even
yeah,
I'm a fresher like into this DevOps. Like I'm getting the things right now by googling and by your. I just saw your last class on 20th is the first. I think right.
yes,
That is the first
yes,
class
correct,
on your end. So
correct.
I have listened to that. So that's why
Yeah.
I was asking you like will it be better way for me in completely changing over this or not?
Yeah, yeah, it is a better way now because Even everything is getting into AI and all these things to make these disturbances clear. Probably DevOps would help you much in understanding and in getting your stagnant position into a flexible thing. So yeah, this would be the right time, and you can use your complete 5 years experience by mentioning that you have the experience of Azure testing, but you can still, after listening to this, you can even put the DevOps concepts as well in the interview that you have helped your Docker DevOps teams and you started working in a DevOps in your previous project itself.
Okay, Kiran. And also, like after all this course, you also helps in providing the, the how to build the resumes and how to
Yeah,
crack
yeah,
the interviews, everything. The last, right?
yes, we will provide everything.
Okay, Kiran. And may I know, like for every session, like how you are providing the notepads, right? Right now, will you provide
Yeah.
this to us other than the recordings?
Uh, we will provide the recordings every day, but coming to
Okay.
Notepad thing, we will provide it. I'll try to provide it after every topic.
Yes, sir. Please do that. It would be helpful.
Yeah, yeah, sure. We'll provide that after every topic because in between, if I provide this, it could be like confusing for you all. So after every topic, we'll try to provide the Notepad as well.
Okay, sir. That's it. Thank you so much.
Yeah. Any other questions for anyone?
Yeah, hi Kiran. This is Naveen, and today is my first demo on this Terraform and
Yeah.
Kubernetes. Actually, I'm working in an MNC, and I have a total 10 plus years experience in industry. And currently, in my project, we are using NetApp and the backend to that, and we are using AWS. So
Okay.
on-premise, we are using NetApp, and for that, and for cloud also we are using AWS, and for that our project is requirement is we need to have the knowledge on Terraform and Kubernetes. So will it
Okay.
be okay for me? And the requirement is not now. The requirement is up to in coming next February.
Okay.
So will it be okay to meet? I'm that I can assure and that I can compatible with the Terraform knowledge by Feb.
Yes, you can. So you have ample enough of time, and we will discuss from scratch level for the Terraform and also how to deploy the Terraform and how to create the infrastructure using Terraform, how to deploy applications using Terraform and YAML for GitHub, GitLab, CI/CD, AWS, or Azure. So you have like 3 to 4 months from now. So you have the ample enough of time. So
Yeah,
that's
because
why, yeah,
yeah, the is splitting in our organization, and that entire the new storage areas also the environment is setting up from the scratch. So the all the transition is going on now. So after
yeah,
December, they'll start and will go live by February or March of 2026.
got it. So yeah,
Yeah,
that's what I mean. With this training, you'll have enough of time to practice, and also you'll have good knowledge on what it is and how it is. But the only point is not just listening the classes. You start
yeah,
practicing on it and get used to it, so that you will be in a confident manner by Feb.
yeah, yeah. Even we have that, access in our office also for that to in the labs also are available for us. So that is what I'm requesting.
Okay. Yeah, I mean, even the Terraform and all these are open source platforms. It's not just like you can use only the Office or licensed versions. It's open source, so you can use it everywhere, even in your personal laptop also you can use
Yeah, thanks a lot. Kiran. Yeah.
it. Okay. Yeah. Any other
Kiran,
questions to any? Yeah, Sushmita.
yeah, whatever we use, I mean, whatever we learn in this course or in this training, no? So, can we? All the application will be hands-on, right? I mean, we can do hands-on, and it will be free of like
Yes,
we will
yes,
get in.
yes.
It
It's
is like a
open source
open
and
source.
you'll get a hands-on. Yeah, correct.
Okay. May I know like how long will be the courses?
It's like we are planning for 1 hour, 30 minutes of session every day, 45 days, or 1 hour session with 60 days. So we'll yet to decide that. But it could be either 1 hour, 30 minutes every day or 1 hour every day.
Okay,
And
Kiran.
so from this batch, we are also trying to implement like from Monday to Thursday, we'll have the theoretical and practical classes. On Friday, everyone would be on only on the laptop and they will share the screen and we will try to run the applications from your laptop and you will be running that laptop so that you will be on a hands-on with a confident manner that what you have learned from Monday to Thursday.
Okay, the timings will be same, right? Since
Yeah, yeah,
morning.
same,
Okay, okay, I'm
same,
comfortable
7:30.
with. Yeah.
There is no
Can
change in the timings. The batch is 7:30. Yeah, man.
Kiran, I wanted to understand this. Like you explained, right? We will be having multiple scenarios. Like if you are working, you are explaining Terraform. Will it only you will only explain it on Azure or AWS instances also?
I will give everything. I'll give the code of complete. So if I explain one cloud task, I would sorry, if I explain on one cloud, the task for you would be on the other cloud.
Got it, Kiran. Thank you.
So that you'll have the uh, habit of Azure as well as AWS.
Currently, I'm designated as a senior cloud engineer, but in the project, it is nothing relevant to that. And this is my second time, maybe learning from you and getting the information. First time, I cracked the interview in Sonata. So
Oh, okay.
that time, oh yeah, that time also, I guess you were my trainer and
Yeah.
got ample amount of information from you. I cracked it, and but once getting into the team, I got to understand that they recruit for one thing, but as per the project requirement they deploy you into the project. And after
Yes.
that
Correct.
there was nothing relevant to the things which I got to learn. Normally I was trained on how we create CI/CD pipelines, multiple environments in the pipeline and all, merging
Yeah.
strategies, all those things were explained by you. But going forward, when I try to implement that in the project got it got over, and we moved to some other project. And now again everything is I mean, I got to learn everything from scratch because I don't have enough hands-on experience to switch.
Got it. Got it. That's nice to hear. I mean, you got placed somewhere by using the knowledge what we share. But at the same time, this time we'll also try to practice in a way that it will go ahead and get you to learn all the other things as well, and you can implement in your project.
Thank you, Kiran.
Yeah.
Kiran,
Anyone have? Yeah, Sushmita.
for this
Hello?
Azure, yeah, you can hear me, right?
Yeah, yeah, I can hear you. Go ahead.
No. Azure admin and Azure DevOps, the training also started, right, last week. So that also you are be the trainer, or that is a different
Yes,
team?
yes. No, no, I'm the one.
Okay, Kiran. Yeah, which one is the better? Like as I said, I am. Which will be the future scope more, like that one or this? Like,
See, everything has its own specific manner, but our topics covers most of the things with all the other different clouds as well. So it covers most of the things. So I would not say that I mean that this is more specific or this is, but see, comparatively everything is dependent on cloud, everything is on CI/CD, everything is on different clouds. So the only point is it has its own scope and it has its own things.
Okay, Kiran, got it.
Okay, any other questions? Okay, if there is no questions, we'll continue tomorrow. Thank you.
Yeah, thank you, Kiran. So tomorrow also 7:30, right?
Same 7:30. Yeah.
Okay. So when this actual live sessions will be held, because these are demos, right?
So we are no no the we are going with live as well. These are not just demos. We started with the live itself. So
Mm-hmm.
you'll
Okay.
the
Okay.
process will be like this. Yeah.
Oh,
If you
okay.
see,
Sure.
we have went into Docker desktop and we have seen the uh, how to create the containers as well. So it's not just a demo. It's like live itself.
Okay. Sure. Understood. Yeah.
Okay. Yeah. Thank you.
Yeah. Thank you, Kiran. Thanks a lot for your valuable time. Yeah.
Thank you. Thanks everyone.
Thank you, Kiran.